Let us see what is there in this question. Which of the following reduces the energy losses in a transformer? So we are basically working with the transformer and we want to reduce the losses. Before reducing the losses, we must understand what are the losses which are associated with the transformer. So the first loss is actually known as copper loss. Copper loss is the loss which is happening because of the copper wire that we are using to create the windings, the primary winding as well as the secondary winding. Obviously, when we say that the number of turns are like 250 turns and all that, obviously the length of the wire becomes really very big and the resistance obviously will become really very high. So whatever is your current which is passing through in the primary or the secondary, there is a loss which is related with I square R losses. Their losses are known as copper losses. Now, point number two is eddy loss. Now, eddy losses are the losses which happen when you are using a solid chunk, when there is a variable magnetic field and due to which there is a variable magnetic flux associated with that solid chunk, which give rise to the induction current of various types, and those induction currents are basically moving in a very vague manner there, and so it starts creating losses of energy there, like the system gets heated up, and so that gives rise to a current which is actually not controlled. So there is a power loss associated with that, and even that is I square R, but that is not in the wire. That is why we do not call it copper loss, but we call it eddy loss. So eddy loss is when you are using a solid chunk there, like this, and there is a flux associated with this chunk, and so the currents start flowing like this. That is why there is a certain kind of loss associated. This is known as eddy loss. How do we reduce it? We reduce is by not using a solid core. And what else do we use? Then what we do is we divide this solid core into slices like this, like butter slices, isn't it? Yeah, we divide this thing into very thin slices and then we laminate each of the slice and then we bind them together to again make a very big chunk that is used as a transformer. Okay, so this is how we do it, and the eddy losses can be reduced by using laminated core instead of solid core. Now point number three is like there is a bit of flux loss that is involved, so we want that flux loss should not happen, so we try to use a material just like soft iron and others, those who have the property of not leaking the flux. So the flux that enters into the solid mass, it remains within the solid mass, it does not get out of it, and this is what we want. And so the flux loss is again the third kind of loss. Point number four, that just because we are enumerating all of the losses in a transformer, so there is something called humming loss. Humming loss is a loss um, because you see there is a sound coming from the transformer every time, like you are standing below the transformer. Stay away from it, by the way. But if you're actually staying near to it, like let's say, you would be listening to a noise, humming noise, like this kind of noise is coming out of a transformer. That noise is called humming loss, and we cannot actually do anything about it. So obviously sound is created by some energy, so there is a loss of energy happening there. Now point number five that I would say is what was that loss? I just having that thing in my mind. Just a moment. Couple of flux loss, humming loss, and hysteresis loss. So there is something known as hysteresis loop. Now this is not in your syllabus. You people have not read it, I believe. Um, it looks something like this. But if you know it, anyways, it's good. So hysteresis loss happens when the magnetism is reversed every time, like this time and this time. And so there are a couple of hysteresis losses. Need not to go into details. Okay. So these are the total number of losses which can ever happen when you talk about the transformer. Let us now go for the options. So A option says using a thinner wire for the windings. Well, if you are reducing the cross-sectional area of a wire, you are in fact increasing the resistance of a wire. It means that you would be increasing the copper loss. So A is definitely wrong. Point number B is using a solid core instead of a laminated core. Absolutely wrong. Instead of a solid core, we have to use a laminated core if we want to actually reduce the losses. So B is also wrong. Let us go for C. Using a core made up of steel instead of iron? Not at all, because I told you that that is the property of soft iron. Soft iron is a special kind of an iron, which is used in the creation of transformers. And the property is that the magnetic flux that enters into the solid once, it never gets out of it. It is caught in between the solid only. So even C is wrong. Definitely D should be the correct answer then. But let us see. Linking more flux from the primary to the secondary coil. Well, definitely yes, D is a correct answer, because we do not want the flux to be lost, and the primary flux has to be linked with the secondary flux. The losses of the flux should be very less, but they are not talking about like how that is achieved. But still, D is the correct answer for this question, no doubt about that. So D will be the correct question. So this is how we solve this question, my dear student. In this topic, I have given you all of the losses that are happening in the transformer, although I believe they are not given in your books. So it is an additional source of information. I have added those things. Okay, my dear students, all the best. This is Professor Varun. Take care. Bye.